Hey everyone, welcome to the third lesson of Unit 5. The first two lessons we focused on solving quadratics in two different methods. We talked about the first method was by factoring, and the second method was by the square root method. The square root method, remember, was the more direct way of solving a quadratic, and we could do that when we just had an x squared. We didn't have any x terms, or in other words, we didn't have any b values. We only had a values and c values. Factoring works when you can factor. If you can't factor, if you're not able to do the quadratic factoring in any way, then factoring is not going to work. So the quadratic formula, however, today is going to be the third method that we learn or that we use to solve quadratics, and that is the quadratic formula. The quadratic formula is used when all other methods fail. It is a method that will always work. Okay, so it's used to solve the quadratics of the form ax squared plus bx plus c equals 0. So just like in factored form, you have to make the equation equal to 0 by moving everything over to one side. You have to do the same thing here, okay? It always works. Like I said, it will always give you some sort of answer. It will even tell you what kind of answers you get, whether you get real solutions or imaginary solutions, okay? And yeah, there it is. It shows real and imaginary solutions. So make sure you go ahead and write those 3 points down. It's important. Now, here's what the quadratic formula is. It's a formula that when you plug in the a, b, and c values into this formula, you end up with the solutions for x. And it's this: x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Oops, all over 2a. Now, what you'll see here, you should recognize this. Look at this. We have our negative b over 2a right here. Negative b over 2a, remember, was our axis of symmetry of a quadratic. There is a connection here, okay? And we're going to talk about that in this lesson here, okay? Negative b over 2a. Now, I do realize that this quadratic formula is pretty intense. There's a lot of letters. There's a lot of symbols. A lot of things to memorize. This is something that you want to memorize. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you Google the quadratic formula, if you YouTube the quadratic formula, you will find literally thousands of videos of students creating songs for the quadratic formula. And the reason they're doing that is because their Algebra 1 teacher or their Math 2 teacher says, I'll give you extra credit if you can create a video with a song of the quadratic formula. I'm not going to do that because I believe that your grade should be based on content knowledge here. So I'm not going to give you extra credit for creating a song. But I do encourage you to look those videos up and watch them and try and use it to memorize them. There's lots of different combinations of songs that you could use, okay? So with that said, how do we do this? Well, step one is to make sure that the equation is equal to 0. So you want to move everything over, like I said, to one side so the equation equals 0. If you can, try and make it so that the a value is a positive value, okay? So if you have to move things over, try and move things over so that the a value is positive. It'll just make your life a little bit easier. Step two is to identify your a, b, and c values, just like you would to find the axis of symmetry. And step three is to substitute those values into the formula. So you're going to take the a, b, and c and plug them into this formula, and then you would simplify. Step four is to simplify, okay? So we'll talk about kind of a routine that will help us do that a little bit easier so we don't make some mathematical errors that are pretty common, okay? So let's go ahead and look at an example of this. We want to solve 3x squared minus 11x minus 20 equals 0. So let's go ahead and do that. 3x squared minus 11x minus 20 equals 0. So remember the process here. I've got the process all listed out here. Step one is to make the equation equal to 0. Well, we can see that the equation is already equal to 0, so we don't have to worry about that step so much. Step two, it says to identify our a, b, and c values. So we're going to do that. Our a is 3, our b is negative 11, and our c is negative 20, okay? Now, from here, Step 3 is to substitute. So we're going to substitute into this formula. I'm going to give you two different methods to see this. We would write down x equals, well, let me write down the formula here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when we go to substitute into this formula, we want to put parentheses around all the numbers that we're plugging in so we don't screw up on the signs. So this is negative b. Well, b is negative 11, so we're going to put negative for this negative, and then in parentheses, we're going to put negative 11, negative b, plus or minus the square root of b squared, so parentheses, negative 11 squared, minus 4 times parentheses, the a, which is 3, and then the c value, which is negative 20. Okay, all over 2 times a, so parentheses, whatever a is 3. So that is the formula, okay? And our job now is just to simplify this. Well, when I go to simplify this, remember your order of operations, PEMDAS. Please excuse my dear Aunt Sally. We want to do parentheses first. Now, these parentheses that I have written here are there so that we don't screw up on signs more than anything. The parentheses that I have here, there's nothing to do inside the parenthesis because it's just negative 20. It's just 3. So there's no operation to do inside the parentheses. The next step is to deal with exponents. Well, let me take a step back. We should recognize that the numerator is in fact a set of parentheses. Anything on top is in one parenthesis, and anything on the bottom is in another parenthesis, okay? I think some teachers call this grouping. Parentheses is grouping. Gamma, grouping exponents, and then multiply, divide, and then add, subtract, gamma. If you remember that, I'll go ahead and write that down, gamma. I just thought about that myself, just remember that. So G is grouping, E is exponents, M is multiply and divide, A is adding and subtracting, okay, if you remember it that way. But okay, those parentheses. We also recognize that we have parentheses inside the radical. This radical groups all the stuff inside together, okay? So really the first step is to simplify what's inside the radical. Well, what's inside the radical is an exponent and then a bunch of multiplication. So we want to do the exponents first. So we would write this out. X equals, we're going to carry everything else down. So negative 11, we're not dealing with that yet, plus or minus the square root of, now, negative 11 squared. Well, negative 11 times negative 11 is 121. And then from there, we'll copy everything else down, okay, all over 2 times 3. Okay, as we go through this, it will get quicker because you'll learn that there's certain things that you can do all in one step. From here, we got to deal with what's inside the radical still, so we're going to carry everything else down. So we're going to leave 121 there. And then we're multiplying the negative 4 times the positive 3 times the negative 20. Now, you guys are going to be allowed to use a calculator on this next test. So we might as well put it right next to it here. We've got, let's see, what was it? Negative 4 times 3 times negative 20. And then we'll hit enter. And we end up with positive 240. So we're going to put plus 240 there. And that makes sense. A negative times a negative is a positive. 4 times 3 is 12, times 20 is 240. All over 2 times 3. And then we will add what's inside the radical here. So we get negative 11 plus or minus the square root of 121 plus 240 is 361. And then all over 6. All right. So there's that. Now, if we can, we should square root this. So we would simplify the radical if I want it in radical form, and we would just plug it into our calculator and get the square root of 361 if I want in decimal form. Now, the answer I get here is going to be nice and clean for the most part because I want to compare this to the other methods or the other method factoring to make sure that we agree here. But I'm going to go ahead and take the square root of 361 with my calculator. And remember, when I take the square root of 361, I'm going to hit second square root. So that's this button here, if you have this kind of calculator. 361, and then close the parenthesis and hit enter. And I end up with 19. So the square root of 361 is 19. So we're going to write down negative 11 plus or minus 19. Now, I kind of cheated here. I put a 6 on the bottom, and that's okay to do in this case because 2 times 3 is in its own set of parentheses in the denominator. So I can simplify that separately from simplifying the top. Now we're going to simplify the top a little bit. We have negative 1, that's multiplication here, and then adding and subtracting, well, we do multiplication before we add and subtract. So negative 1 times negative 11 is positive 11, and then plus or minus 19 over 6. Now from here, it's going to be important that we separate the answers here. We have 2 separate answers. We end up with 11 plus 19 over 6 and 11 minus 19 over 6, okay? Then we'll just simplify that. We have to simplify the top. 11 plus 19 is 30, and then over 6. And then 11 minus 19 is negative 8 and over 6. And then we can reduce those. Obviously, 30 divided by 6 is just 5. And then the 8 and the 6, those both reduce by 2. So you end up with negative 4/3. So those are the solutions to my original equation, x equals 5 and negative 4/3. That's how you use the quadratic formula. Now, kind of going through this to make sure we understand what we can and can't do in order to simplify this a little bit easier, let me go ahead and do it again. I'm going to rewrite it, negative 11 plus or minus the square root of negative 11 squared minus 4 times 3 times negative 20 all over 2 times 3. Okay, so we're trying to simplify this. What can we do all at once so that we don't have 10 different steps here, okay? We've substituted. Here's what we can do. We know that the radical is its own grouping. We also know that the exponent is separated by an addition or subtraction between all of this stuff, okay? So we can put the negative 11 squared, we can do that, and we can multiply the negative 4 and the 3 and the negative 20, we can do all that at the same time. We can multiply the negative and the negative 11 together at the same time because that's completely separated from the radical, and we can multiply the 2 times the 3 in the bottom at the same time. So negative 11 is 11. Then we'd say plus or minus the square root of, well, negative 11 squared is 121. And then the negative 4 times the 3 times the negative 20 is positive 240. And then on the bottom, 2 times 3 is 6. So what we did there is we actually cut out a bunch of steps that I showed you prior. We can do this part first. Let me go ahead and circle this. We can do this part. We can do this part. We can do this part. And we can do this part all in the next step and still be okay. And we can do that every time. From here, we're going to add what's inside the radical. So we get 11 plus or minus the square root of 361 over 6. So we can't cut that step out. And then we've got to take the square root of 361. So that'd be 11 plus or minus 19 over 6. And then from here, we'll break it into the 2 cases, 11 plus 19 over 6 and 11 minus 19 over 6. And then solve each of those separately. So that'd be 30 over 6 and negative 8 over 6, which is obviously 5 and negative 4/3 like we said before, okay? So just trying to cut down on the amount of steps that we're working with here. Let's go ahead and solve this equation by factoring what we did in lesson 1, because I think we need a reminder of that. We don't want to forget it just because we have the quadratic formula now. But that way we can compare and kind of solidify in our minds that this quadratic formula actually does work. So remember, when we solve for factoring, we get everything equal to 0, and it already is. Then the next step is to factor, so we do our x factoring. 3 times negative 20 is negative 60, negative 11 on the bottom. So our factors, let's see, that's 1 times 60, 2 times 30, 3 times 20, 4 times 15. It looks like that one's going to be the one. 5 times 12, 6 times 10, and I think that's it. Yeah, I think that's it. So it's going to be 4 and 15. And now let's look at our signs. Because we want a negative, one of these has to be negative. And because the negative 11 is being added, that means the 15 has to be negative, the bigger number. So then we'll go ahead and expand this. 3x squared plus 4x minus 15x minus 20. And then we'll group. So the GCF there is x times 3x plus 4. The GCF here is negative 5 times 3x plus 4. And so our factors are x minus 5 and 3x plus 4. And remember, that was equal to 0. From here, we do the zero product property. So we say x minus 5 equals 0 and 3x plus 4 equals 0. And then we solve each one of these equations. So here we're going to add 5 to both sides. And we end up with x equals 5. And then here we're going to subtract 4 from both sides. And we end up with 3x equals negative 4. And then divide by 3. So we end up with x equals negative 4/3. So we can see that the solutions that we got when we did the quadratic formula, let's put this right next to it if I can. The solutions I got when I did the quadratic formula were the same. X equals 5 and x equals negative 4/3. And here in my factored form, I have x equals 5 and x equals negative 4/3. So that makes sense. That works. It should work. We should get the same answers if I'm dealing with the same equation. Now, you might say, well, why are you giving me this new method if the old method worked? Because factoring isn't always possible, okay? So we have to have a different method to solve when factoring doesn't work. And that's going to be our next step here. What do we do when factoring doesn't work? What does this look like when factoring doesn't work? So with that said, go ahead and practice this problem using the quadratic formula. Let's see how far you can get. Pause the video and then come back and push play when you're ready. All right, for this problem, number 1, we got 2x squared minus 5x equals 7. We're trying to get, first step is to get x by itself. Sorry, the first step is to get it equal to 0, so we're going to subtract 7 from both sides. And we'd end up with 2x squared minus 5x minus 7 equals 0. Then we identify our a, b, and c values. A is 2, b is negative 5, and c is negative 7. And then we would plug that into our quadratic formula. So remember, our quadratic formula is x equals negative b, so negative parentheses, negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times 2 times negative 7, all over 2a, so 2 times 2. So you should have been able to substitute that in correctly there. Remember, parentheses around everything. Then we're going to do the negative 5, that's going to be 5, plus or minus the square root of, we're going to square the negative 5, so that's 25, and we're going to multiply the negative 4, the 2, and the negative 7. Negative 4 times 2 is 8, times negative 8 times negative 7 is positive 56, and then over 2 times 2 is 4. So there we have that. Now we'll go ahead and simplify that. The radical, so that'd be 5 plus or minus the square root of, looks like 81 over 4. So this actually works out very nicely too, because the square root of 81 is just 9. So we end up with 5 plus or minus 9 over 4. Then we'll break it into our two cases. So we get x equals 5 plus 9 over 4 and 5 minus 9 over 4. And then from here, simplify. So x equals 14 over 4 and negative 4 over 4. Or we can say, simplifying that, 7 over 2 and negative 1 as our solutions. Okay, so that's how we do that problem. Let me just double check to make sure we are right. And we are. So that means I'm doing something right. Hopefully you are doing something right. Let's go ahead and take a look at a couple more practice problems. I want you guys to do these on your own. And then when you get stuck, come back and push play and compare how you did here, okay? Use the quadratic formula. All right, for number 2, we've got 8x squared plus 4x minus 16 equals negative x squared. We want to get everything equal to 0. So we could either move all of this stuff over to the right or this over to the left. It makes sense to move this because it's less to do. And it's an x squared. So I'm going to add x squared to both sides, and it combines with the 8x squared. So we're left with 9x squared plus 4x minus 16 equals 0. Then identify our A, B, and C values. A is 9, B is 4, C is negative 16, and then plug into our quadratic formula. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times 9 times negative 16, all over 2 times 9. All right, simplifying that, the negative 4 is just negative 4. Then we have 4 squared, which is 16. Negative 4 times 9 times negative 16. Negative 4 times 9 times negative 16 is going to be a positive value because a negative times a positive is a negative, times a negative is a positive, so we're going to put plus. And when I multiply all those together, I end up with 576. And then all over 2 times 9 is 18. A little bit more simplification with the radical. Negative 4 plus or minus the square root of, that's going to be 592 all over 18. Now, if I try and type into my calculator the square root of 592, that's not going to come out as a nice, clean answer. It's going to be a decimal. It's going to be irrational. We end up with 24.331, blah, 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 blah. So what I would like to do is put this in simplest radical form. And we know how to simplify a radical, so let's go ahead and do that. We need to prison break the 592. So we're going to do that separately. We're going to deal with 592 out here. I'll go ahead and do the cake method. 592 divided by 2 is going to be, what, 250 and 46, 296. And then divide that by 2 again, we're going to get 148. Divide that by 2, we get 74. Divide that by 2, we get 37. And 37 isn't going to work for anything. So we have the square root of 592 is 2 times 2 times 2 times 2 times 37. Circle our pairs, and so those go out. We're left with 4 radical 37. Okay? So let's go ahead. Instead of 592, we're going to write, or the square root of 592, we're going to write square root of 4 square root of 37. So we're going to say x equals negative 4 plus or minus 4 square root of 37 all over 18. And then from here, we're going to simplify. We're simplifying the fraction, and remember we have to reduce both of these, okay, just like we did before. And so we have to look for a common factor between all 3 terms. The common factor between 4, 4, and 18 is going to be 2. So we're going to divide all of those by 2. And so we end up with x equals negative 2 plus or minus 2 radical 37 over 9. Okay, now that's as simple as it can get, but now we want to break our answers up. It'd be x equals negative 2 plus 2 radical 37 over 9 and negative 2 minus 2 radical 37 over 9. Now, these are disgusting answers. I am not denying that whatsoever. But these are the kind of answers you get when the equation is not factorable, okay? Now, if we wanted to put this in decimal form, we would take the square root of 37, and then whatever that is, we'd write it out, and then we'd simplify each of these, okay? So, but this is simplest radical form here, okay? All right, let's take a look at the next problem and see what we can do with that. So for number 3, we have 9x squared minus 30x minus 25. Sorry, said that wrong. Equals negative 25. We are going to add 25 to both sides. Notice that negative 30x and the 25 are not like terms. I'm just putting them under there to get it over there. So it'll be minus 30x and then plus 25 equals 0. So A is 9, B is negative 30, C is 25. So x equals negative 30 plus or minus the square root of negative 30 squared minus 4 times 9 times 25 all over 2 times 9. All right. From here, we're just going to simplify as best we can. The negative 30 is 30 plus or minus the square root of Well, negative 30 squared is 900. 4 times 9 times 25. Well, negative times a positive is a negative. 4 times 25 is 100 times 9, interesting, is 900. What's that going to do for us? Well, 2 times 9 is 18. Watch what happens here. This is kind of cool. X equals 30 plus or minus the square root of 0. Square root of 0. What is the square root of 0? That's a nice, clean, whole, perfect square. The square root of 0 is 0. And so when we go to break this up, if we need to, we would write x equals 30 plus 0 over 18 and 30 minus 0 over 18. Well, guess what happens? These answers are the same. 30 plus 0 is 30. 30 minus 0 is 30. So we only get one answer out of this. We can reduce that now. We can divide both the top and the bottom by 6. And so we end up with x equals 5 over 3. We get one answer in this case because we took the square root of 0. There's only one square root of 0, right? And so one solution. We would say in this case we have one real solution here. This is the first time I think I've really dealt with having one real solution. Okay, we know that we can get two real solutions, two imaginary or complex solutions, but here we have one real solution. We'll talk more about that in the future. All right, hopefully you're plugging along here just fine. Hopefully you're following all this. Quadratic formula. Let's go ahead and take a look at one last problem, and I want to kind of make some connections with this problem. In this problem, I want to find the x-intercepts. So if you think you can do this on your own, go ahead and do that. Oops, as I give you the answer. There's at least part of the answer. But go ahead and do it and verify that that's what you get for your x value. And then we'll talk about what this means in just a minute. All right, for number 4, it says find the x-intercepts. Remember, finding x-intercepts happen when y equals 0. So we need to set the equation equal to 0. We set y equal to 0 here. So it'll say 0 equals negative x squared plus 6x minus 3. Then we do the quadratic formula. So a is negative 1, b is 6, c is negative 3. Plug that in. X equals negative 6 plus or minus the square root of 6 squared minus 4 times negative 1 times negative 3, all over 2 times negative 1. Simplifying that, we end up with negative 6 plus or minus the square root of 36. A negative times a negative times a negative is a negative. 4 times 1 is 4, times 3 is 12, all over negative 2. And then we end up with x equals negative 6 plus or minus the square root of 24 over negative 2. And then we can simplify that radical. I'm not going to spend a long time doing that. Let's see, that's 6 times 4, so it's going to be 2 radical 6 over negative 2. And then we'll break it up into the two cases. We would get, well, actually, we could go ahead and reduce this first. We recognize that all three terms are factorable by 2, are divisible by 2. So we end up with negative 3 plus or minus 1 radical 6, or just radical 6, over negative 1. Our two cases then are x equals negative 3 plus radical 6 over negative 1, and negative 3 minus radical 6 over negative 1. Now, because that's over 1, I can actually simplify that a little bit further. What if I divide all of this by negative 1? Negative 1 is a common factor in all of those. Okay, so we end up with 3 minus radical 6 over 1, and then we end up with 3 plus radical 6 over 1. So those are my solutions to the equation with the 0 there. Now, if I want to put this in decimal form, I think that would be a good idea. So I'll type in square root of 6, and I end up with 3 minus 2.449 and 3 plus 2.449. And so I have x equals, and then we'll say 3 minus that, and we end up with 0.551 for the first one, and the second one would be 5.449. So these are my solutions in decimal form. So radical form, decimal form. Now, what are the x-intercepts? The x-intercepts would be written as 0.551, 0, and 5.449, 0. And that is the answer to this. But I want to go a little bit deeper into understanding what's happening so that we can recognize how this quadratic formula relates to a graph, okay? So there's my solutions. I'm going to go ahead and keep those on the board here. What I want to do next is graph this parabola so we can see the connection that's being made. So let's go ahead and do that. Remember, how do we graph a parabola from standard form? Well, we have to find our axis of symmetry. And if you remember, to find your axis of symmetry, it's x equals negative b over 2a. Remember, that's part of the quadratic formula. We end up with negative 6 over 2 times negative 1, which becomes negative 6 over negative 2, which is 3. Then we plug that in, so we got negative 3 squared plus 6 times 3 minus 3. Do our exponents first, so that's 9. Then we'll do our multiplication. So we get negative 9 plus 18 minus 3. And then negative 9 plus 18 is 9, minus 3 is 6. So our vertex is going to be 3, 6 here. From there, let me get my graph out so we can see what's happening here. We've got a vertex of 3, 6. So I'm going to go to the right 3 and up 6. And then I'm going to follow my slope pattern. And so you guys can see that the slope pattern is negative 1. So we're going to go down 1 over 1, and then down 4 over 2, and then down 9, 2, 4, 6, 8, 9 over 3. And we'll reflect it on the other side. And we can verify it because our y-intercept should be 0, negative 3 here. And I apologize, this axis is a little bit too light to see anything on it. That's okay. Okay, so you can see that the y-intercept is actually negative 3. Now, if I connect these, if I draw curvature, and be careful with it, what do I notice? Well, let me highlight this. Remember, the axis of symmetry is this line that the parabola is reflected about, basically. One side of the parabola is. What I want to draw your attention to is that we got a solution that said something like this for our x-intercepts early on. We got x equals 3 minus 2.449 and 3 plus 2.449. Those were the x values of our x-intercepts. Well, where did that come from? That came from this idea here that our axis of symmetry is 3. Our axis of symmetry is 3, and we subtract 2.4. So if I take 3 and I move over back, I subtract 2.4, I'm going to get right about there. There's my x-intercept. And then here I'm starting at my axis of symmetry, and I'm adding 2.4. And so I end up with something like that. So we can see that this actually makes sense. Our x-intercepts are starting, we could look at it as starting on the axis of symmetry and moving this amount, some amount to the left of it and the same amount to the right of it to get our x-intercepts, because those should be equal distant from our axis of symmetry. Now, in this case, we didn't get nice, clean, whole numbers like we have been in the past, but that was the purpose of the quadratic formula when we don't come up with nice, clean, whole numbers. All right, with that said, I hope you see that connection. I hope you see the value of the quadratic formula in terms of solving quadratic equations. If you have any questions, please comment below or reach out to me in a tutoring session, and I would be more than happy to help you out. With that said, I'll see you again next time.